Brett Ramirez, Associate Professor in Agriculture and Biosystems Engineering at Iowa State University. He really leads an integrated research and extension program that focuses not only on ventilation design and management, but climate physiology, mass mortality management, and multiple other topics related to swine facilities. So we'll jump into this with Brent on innovation, potential, and limitations of smart controllers.
All right. Thank you all for having me here. And Marlon, if you organized this session in the order, you did an excellent job.
I did not. That was Mark.
Thank you, Mark. That was excellent flow of information. So the first two speakers did a great job of covering all the things we commonly see and best practices. And so I'm going to probably take a little bit more of a philosophical approach, just because I guess I'm a professor and that's what I do, is sit around and think all day. So that's what I'm going to kind of talk a little bit more about is philosophy, and then also kind of get into how technology is integrated and how it's working its way to change, I think, somewhat of how we manage ventilation systems. So, perfect segue from Sam. It doesn't matter how expensive or high-tech or sophisticated your controller is, and I'll extend that to any actual piece of technology for that matter, is, for controllers, if the settings are wrong, we just heard, it's going to lead to a bad environment. Or it could lead to excess energy usage. The controller really only does what the human programs it to do. Until our controllers are self-learning and can figure out some of those situations, which I think they might do here in the near future at some point, like probably a controller could figure out by running its heaters, how far up does the temperature go, and then slowly adjust its own offset to figure out what is that sweet spot to always keep the room temperature 0.2 of a degree below set point. And it'll just do that, so whether or not you run maybe a degree below because your offset's big just to be safe and trying to avoid wasting propane, controller might be able to do that in the future. Now, the probably biggest one for me in the last couple years of noticing, if the equipment doesn't work, the controller can't control the environment. I mean, that is probably one of the biggest ones I've noticed in a lot of barn visits is just stuff doesn't work. And I just at some barns on Thursday, I've already got pictures in here from that. There was a bunch of fans that didn't work. There was fans with holes in them, belts that were loose. And really, we can't get to a level of a good environment without the equipment functioning. And that, I think, is probably one of the biggest ones that, in order to really promote that change, is we have to keep the stuff working. Another one is the facility was poorly designed, or we put in the wrong equipment. The controller's not going to change, and that environment and the energy is going to be affected, right? It starts with the facility design. It's really hard to change a barn after you build it. Once it's up, and you're kind of more or less going to have to deal with that over time. Equipment maintenance, saw some good pictures of that. Like Sam touched on the sensors, I'm going to talk a little bit more about that because, and there's a perfect last bullet on the garbage in, garbage out, because as we go into more technology, it really relies on electronically created information, and if that information's bad, we're not going to have a good outcome. Another thing I often see is the first thing, I like to start with walking around the barn and then we get into it, but then always the first stop is right at the controller. And it's like, well, hold on one second, there could be some other things out there that we might need to look at first that could most likely be the cause, but then more often than not, the controller probably is at fault, but it's again, trying to get that culture of not just, my problem's gotta be something with the controller. It could be, but you gotta get around and put together all these pieces. Ventilation is really an art and a science, and I after thinking more about that, I do believe that, that there is some science, there's the math, there's the physics behind it, but then there's that art part that really comes into that individual grower, manager, or whoever's in charge of trying to figure out how to make that particular system work. So this was just sent to me the other day, and I think it's a great example of how humans and technology interact. So this was a screenshot of the fact that the temperature probe alarm tripped, missing sensor. Started on September 11th. The sensor was still missing 4 days later. So with older controllers, you wouldn't know that, right? It's not able to tell you that information, but with today's technology, it can tell you now that you're missing a sensor and you probably want to go get that fixed. However, who's got to go replace the sensor? a person. And so it's up to the humans to interact on what they do with that information. This one's a pretty self-explanatory one. You just need to go put in a new temp probe. Do you need to make sure it's the right one? Same cap color? Yes. So there's a few other nuances in there to make sure we get it right, but it's a good example of it, probably needed to do that sooner because that controller is making its decision off one less probe than the average. And then we already saw some good examples. Here's some things, but again, technology can't fix this stuff, and this is what leads to a good or a bad environment. So we can invest a lot of money in technology, but this is what's going to actually change the environment. And so, things like, I think we have the same picture here. It's a good one. Clogged soffits, gaps under pit covers, improper soffits. This one I just saw the other day. Holes in a pit fan. There's probably 30–40% of that airflow that fan's supposed to be taking out from my room is just short circuiting right through the side of that pit fan. So what does that do to the environment? So you looked at, maybe you went in the barn and all of a sudden you notice, well, it's a little bit more humid, turn up the minimum ventilation speed, but guess what? It doesn't really matter when all the air is going right through the side of the pit fan. Other things with like leaking shutters, the infamous pit fan, bad probe locations, snow falling off, hitting cones, but really the important part is this is where to start, and once we get this part right, I think we can really build from that. So again, more on the philosophy side, I think it starts with good ventilation design. If we skip this step, it's really hard to get the next 4 pieces correct. Next part comes construction. I know most of us really love working with contractors and the great job they do in following instructions. But to get a design to work, it's got to be built correctly and installed correctly, because once you get that first disconnect between the two, it still creates a waterfall of issues. Next part is control. Right? Controllers are somewhat generic in the sense that they are pre-programmed to do something, and then the human must put their correct settings in, but the controller doesn't know what the equipment is, how the barn's built, and all these other nuances that's going to affect its ability to control the environment. Once the controller's set, it's going to run regardless of how everything else interacts with that system. Then lastly, where I think there's some great opportunity is really in monitoring. We went from a standalone controller, wasn't connected to the internet, didn't really generate a whole lot of information, to now controllers today generating anything you want. So, tons of information that all can now be accessed from the cloud, remotely accessed, that now gives us this ability to really start to probably dig into some of these environmental conditions and data to make comparisons, figure out how things are doing, maybe promote quicker analyses of the environment to figure out what the problem is, or analyze things like, is my offset too tight? Does my minimum vent bandwidth need to change? Is my speed wrong on my min vent fan? All these things that we might be able to question. And so that's what creates a good environment. So things I think about that I come across is, can you outmanage a bad design? So that's one that I often find interesting, and is it possible? And then, can bad ventilation design create poor management? So which ones of the two does it go? Because I've worked with a lot of different systems, and you come across all these different views on this and how those two interact together. Should we have to manage ventilation? I think a lot of people would say, I would love to never have to manage ventilation and just let it do its thing. But I think we've heard that it's important and that we're trying to bring in more people and expertise to do it, because I think it is something we do have to manage. As much as we'd love to just set it and forget it, it's unfortunately running 24/7, 365, and without it, you got what, an hour? Something like that. So it's kind of important. And then, is the environment a tool to improve productivity, or is it a daily chore? And so that's another one where, talk about expressing the genetic potential of the pigs. I find it as a tool, but, a lot of people see it more as a chore. And so from the two perspectives, where do you find that common ground in getting that to work together? I think another challenge we often see is the capital cost versus the operating cost when we do ventilation. Often we try to build for as cheap as possible, and we try to operate for as cheap as possible. How do those two work together, and does that really create an efficient system for everybody in that system, and for owners, growers, operators? And also another interesting one is, what's the cost of doing something different? That's a tricky one, because if it's wrong, might not ever do it again, and it could change the trajectory of how you do ventilation versus, if you know with what you got and it works, it's not broke, don't fix it. So I think it's just an interesting one, and we're trying to put value on that and how to do it something different. So where do I see the most ventilation innovation? I think a lot of great stuff is going into remote wireless alarm systems, remote access on controllers, wireless sensors. Fan motors have really changed drastically in the last 5 years across small fans and large fans. Even some of our construction techniques with going to just a lot tighter barns, the steel construction with SIP panels, have all been pretty interesting. Kind of in the moderate range is inlets, heating, building materials, sensors, data, system design I see have been changing a little bit. And I think one of the low ones where I haven't really seen too many things change, and I'm guilty of this, I haven't changed my slides since when Jay made them 15, 20 years ago, so I'll throw myself in there on the training side. The training really hasn't changed too much. I think you mentioned we don't do a lot of research on the effects of the environment inside the barn and exactly what should those temperatures be, or what is the impact of humidity on those pigs, the impact of settings on certain things. And so that's why I think a lot more effort, I think we could find innovative ways to start doing that to maybe change the landscape of how we do it. So if you're not familiar, standard TC5, is really involved into what we call today a smart controller, essentially, internet-enabled device that's essentially a computer with a touchscreen and can do all sorts of new things. So I saw an interesting slide, and I copied this from AgriMesh, but when for them, we have hardwired to wireless, stage to smart control, and so I was kind of looking at the landscape of how do these different controllers kind of fit within that and are we gonna see a diagonal trend across there? Are we gonna ever move away from stage control to more probably either proportional control or even maybe a machine learning augmented control, something of that nature. So that's where I think AgriMesh is interesting to think about. Not sure if I would try it, but it's interesting to just think about different ways to manage ventilation or operate a ventilation system. But more or less, with most control systems, we still control ventilation the same. We use a pretty standard stage system, 2 variable speed stages on min-vent and stage 1. But essentially, we do things more or less the same, whether it's in a TC5 to an edge, it's going to more or less be the same. There's some more nuances worked in there, and there's some more things you have control over and things that you could prevent that you can't do on older controllers, I think is again helping shift that needle. So added value and benefits, here's an example. I was at a farm, and I think it's fantastic that we can walk into a screen and look at the amps on our fans. We see there's a group here that kind of looks pretty normal, something I would expect to see on a 48-inch belt-driven fan, I believe. You think tunnel fan 5 was on that day? Nope. Why not? Didn't have a belt. And then what was wrong with tunnel fan 4? It actually stopped working when I was looking at it because it eventually, the motor eventually gave out because of how loose the belt was, and it had to now be replaced. But this is something really quick that we now can see that we didn't have that ability to do in the future. This is how I also did this the other week when I was at a farm, is this also gives me a pretty good indication of what that looks like. But this, I can set an amp threshold on here that will send out an alarm to tell me that it's getting outside of its normal, versus this takes a little bit of training. Somebody's got to understand what is the difference between these two fans. Why is one of these shutters barely open? Why is the other one wide open? Most likely this one, if you look at it, I believe the pulley was pretty worn out or the belt was extremely worn out. Another thing with the new technology, we can start to integrate different sensors. As much as RH sensors don't really hold up too great, same with, I'd say, some other ones. But we now have that ability, if we can still get more robust sensors, mention alarms, the ability to save equipment because we can quickly get to stuff before it overheats. And I think remote access too. So instead of having to drive out to that barn, that might be 6-7 hours away, we can just look in, see if we can troubleshoot it from remotely, and that might save us a lot of time and energy before we have to actually get out to that barn. So when we weigh the values of sensors and control, I think some of the, the advantages is a lot less manual management. So now things have become more automated or can troubleshoot more automatically. I think it's kind of led to maybe some less climate fluctuations, maybe improved performance of equipment and pigs and people. And the important one, I think, decrease that need for lower level decision making. However, if you decrease that need on the farm, because now technology can do it, that means you need to somehow get that information in the system with now higher level knowledge of that to keep that system working and be able to understand how it's working or what the information it's being produced. The disadvantage with technology is developed reliance. So now all of a sudden we just assume that the controller or whatever it is just going to do it, and now we don't maybe need to train people on it, or we don't need to know about it anymore because something's just doing it for us. And also technology costs money. So what's hard is we put things in a challenging environment with a wide range of complexity and different housing systems. And how many different ventilation systems did you say you had? A lot. And then it's got to be technically feasible and economically feasible for it to work in our systems, and then it really has to provide value at the end of the day. And so when most people make a measurement, they assume it will be good enough. And so diving a little bit into sensors and how they work, things you gotta make sure, is what I'm measuring representative of what I'm trying to assess? So that's kind of the first question. Are the results accurate enough? Do I need multiple measurements or a variety of measurements to make a correctly assess the situation? If I just look at humidity for min-vent, that probably will get me pretty close. But is there something else? Do I also need to consider temperature? Yep, because that's what's tied to humidity and how to fix that. Is the device working correctly? And then how critical is that measurement? Or am I going to lose money, or is somebody going to lose their life based on that measurement? And so when we actually measure something, let's take a simple temperature sensor. We have a transducer, which has a sensing mechanism in it. It goes through a signal conditioning process and then a processing part, which is getting the data. Then it's got to be transmitted, so it could go wirelessly or on a wire. It's going to end up on a screen or a dashboard, and then it's going to end up as information for an end user. And so there's a lot of steps in that process that can lead to garbage in equals garbage out. And so, environment alone has an effect on it. Dirt on temp sensors can change their value. Location, as we mentioned earlier, has a huge impact on how that ventilation system is going to react based on where you put those probes in the room. Is it in front of the heater? Is it in front of an inlet? Is it next to the ceiling? Is it too low? Did the pigs eat it? It all is going to have an effect. And so it's a rather complicated process, and as we think about not just something as simple as temperature, but everything else, there's a lot of different variables that go into it, and for us to actually get good, reliable information from those sensors. Controls are complicated. I think I took this at a picture of the farm in Europe, and I just couldn't believe how complicated one can really make this, but if there's a will, there's a way. So you need to keep in mind of all the different styles, power natural tunnel, all these come with their own nuances that we have to have a range of solutions for. And we have to be able to integrate equipment, fan staging. Some systems might only have 4 stages, some might have 16 stages. That's a wide range in complication that we have to account for. Settings, there's a lot of settings. Sensors, we can also add a lot of sensors to these systems. I think the one thing I wanted to mention was that Sam about having something in the room that has all your stages. That is something I completely agree, and I think for bigger systems, absolutely need something of that nature that has just kind of the baseline, key settings, key stages, key fans, and some other things, just because it's so hard to get that information and how many phone calls you need to make to figure that out. And that's what usually if I'm doing an audit, I'll try to write all that down and say, here, do what you want with it, but at least now you have it from a baseline, and then you can make tweaks as you go from there. Establishing criteria, depends on the system. We have so many different things. What level of variable speed fans, variable output heaters, on-off heaters? Do you have brooders, sprinklers, actuated inlets, actuated tunnel curtains? And really these actually become quite complicated systems if we really start to think about it and add things up. So switching into future considerations, one of the things I'm particularly interested in is modeling the transfer of heat between pigs and their environment. I don't think we do it enough, and a lot of the models we use are probably from the 60s and 70s. Find different ways to control the environment based off the pig rather than the environment itself, because we assume that temperature is what tells us everything we need, and really the pig probably should be that indicator, whether it's through its behavior, drinking, eating patterns is probably more representative of what that environment should be like. Other things I think about, barns built today, need to have ventilation and cooling strategies for the next 10 years. I don't think we need to be basing them off of things from the early 90s when we're already, 34 years later and, not building a whole lot of barns now, but as we think about it or remodel, what are those needs going to be either when it's based on the genetic potential of the pig or climate change? One of the two, that barns need to be set up for the future rather than being based on the past. So making sure we have good numbers that often really don't get updated. I see a lot more computational fluid dynamics being used in barns than I've ever had, probably when I started at Iowa State. So it's great to see that being incorporated, trying to make these designs a lot more robust. Data for climate, so these are two examples. This slide's a little bit old, but these were two projects I found out of Europe that's really looking toward combining a lot of the environment data with production records, health records, and actually trying to see that link between the environment and the other aspects of production. So I don't see it done a whole lot, but I think there's a need to start figuring out what is that climate data? Is it useful? Can we use it for something more than just alerts that I've got a high temp alarm, low temp alarm? Can we use it to do something to make strategic decisions on that's going to affect the animal performance? So last opportunities. I saw a while ago there's a really cool group in South Korea that was using virtual reality and augmented reality to do on-site ventilation troubleshooting. So they were overlaying models on goggles so that you could visualize the airflow or other different aspects inside the barn. It was wild. As we see more smart equipment, will a fan be able to tell you that it's going to fail before it fails? So you can maybe prevent that loss of the equipment or the loss of if it's a catastrophic failure. I think construction and building materials are only going to get better. Understand the pig and its environment, designs, energy benchmarking, trying to figure out ways to reduce energy usage on the farms, I think is only going to improve. So the last slide I'll leave you with, I had an opportunity to go to China in June, and we visited Muyan, and this is one of those 6-story pig farms, and we went through their area where they manufacture things, and here's some examples of some of the technology that they've created. So this is their camera that does a thermal image, a depth image, and a digital image that runs up and down a track and sees every pig in the room within an hour, and it just does that 24/7 and feeds them. I think across their system they were getting 1 billion data packets a second. Yeah, just insane. And they have their own controls, their own anemometers, their own I think humidity or CO2 sensor, another environmental thing, but it's just very different than what you usually get to see in the U.S., but it's just kind of interesting to see where things are headed in terms of technology and ventilation around the world. So with that, I'll thank you and take any nice questions.